Yeah, I've heard a lot of my friends tell me that. I was like, I just started trigonometry. I didn't think it was like terribly hard. But they were like, oh, trust me, like it gets worse and all this stuff. And I was like, oh, great.
That's fun. Have no fear. Um,
Yeah.
okay, well then maybe how about I do an example?
Okay.
Okay, in fact, I'll use the triangle that you already found the hypotenuse. Good stuff. It's like this. Um, 20, 21, 29. Okay, we know this is a right angle, meaning it's a 90-degree angle, and
Yeah.
that's all we know. We don't know anything else. However, okay, the trig ratios, by the way, I'm going to put you on the spot. Can you tell me what is a ratio? Just any kind of ratio. What is,
Like
yeah.
like a fraction way of describing things. Like it's like a I don't know, that's the only way I can really explain it. It's like a fraction, but it's like horizontally instead of vertically.
Yeah, no, I mean that's a good way to think about it because the fraction it has the fraction symbol, and that means divided, and it's like a ratio is like a proportion between two things. So a fraction is like a ratio between the numerator and the denominator.
Yeah.
3/4 is like for every three you have a four, and that's the ratio. For every three apples you have four orange. I mean you get that. So yeah, that's a perfect way to think about it. So a ratio is just that. It's like a relationship or a proportion. It's kind of all the same idea. So these trig ratios are the exact same. They're proportions. They're fractions of sides. They're fractions of side lengths. Uh,
Hmm.
so I'm just going to go ahead and just write sine, cosine, and tan all together because you'll probably see some patterns. And using the same, we don't even know what this is. So we're going to call it x degrees. So sine of x degrees, cosine of x degrees, and tan of x degrees represent the ratios or the fractions of these different side lengths. So sine, is opposite over hypotenuse. So that would be 20 over 29. Oh, that looked bad. 29. And what about cosine? What would that be?
Um sorry. Um Adjacent over hypotenuse.
Adjacent over, yep. So in the numbers,
Um 21 over 29, right?
perfect. And tan would be 20 over 21. And then the inverse, I know that you've talked about the inverse a little bit. Instead of the angle measure going as the input
Yeah.
in the sine function, the ratio goes in the input. So like inverse sine or arc sine of 20 over 29 equals x degrees,
Okay.
which equals inverse cosine of, you could fill in the blanks. You could see the pattern like of this also equals x degrees.
Yeah.
Yeah, there you go.
And then so wait, if we put it into the calculator. Oh god, hold on. Yeah, okay. Um so wait, that's not an angle measure. Hold on. I forgot. I have the wrong mode on my calculator.
How pesky those radians. Some people like radians a lot. Actually, I kind
Yeah.
of like them, but they can still be pesky.
Okay, so I got for the inverse of sine, I got 43.60.
Inverse of sine. Okay, so you took inverse sine of 20 over 29. You got 43.6.
Yeah.
Sweet.
So then when I write that in, um between the 20 and the 29 like that, and angle A.
Uh,
Like
well, angle A, no. If you did, 29. I think it'd be angle B.
Oh, sorry. Yeah. 29 over 21.
Okay.
Yeah, sorry. B angle B. Yeah.
Okay.
You're right.
Just
Okay.
checking.
Can we go back to, yeah.